Hello everyone, welcome to my channel Physics Tricks. So in this video I'll be solving all the electrical circuits, right? Like complicated electrical circuits, symmetrical electrical circuit. So all types of electrical circuit in this 10 questions. And if you apply this method, right, whatever I'm telling in this video, if you apply this method in any kind of symmetrical or asymmetrical circuit, right, most of the symmetrical circuit, then I'll assure you that by using this method you can solve any type of electrical circuit easily, right, with ease, we can say, right? So now what is that method? How to apply that? I'll explain in this video. Chalo. So see here we have 9 wires, each of resistance R, are connected to make a prism. So this is the prism given. As shown in the figure, find the equivalent resistance of the arrangement across AD and across AB. That is what we want. We have the answers also. Okay, so now this is the 3D structure, right? This is the 3D structure. We can apply, or we can convert this into the 2D structure. Now just what we have to do is, here we have, this is A, this is B, then this is E, this is F, then we have D and C. I'll mark D over here and C over here. Now just connect all the resistances. So between A and B, one resistance of resistance small r. Between A and E, one resistance of resistance small r. Between E and F, one resistance of resistance small r. Between B and F, one resistance of resistance small r. Between B and C, one resistance of resistance small r. Between A and D, between D and E, between C and F, and between D and C. So all these resistances are given. Okay. Now, and we want what is the equivalent resistance between A and D. Now, see here, whenever we apply across any resistance, right? So it is just the basic behind this. Whenever we have a resistance, and if you apply the potential difference across it, and that potential difference is V supposed to be. Now what does this mean? If I consider at this point potential V, at this point potential must be 0 volt, isn't it? That is what, right? If I consider at this point potential as 2V, this point potential is V. That indicates what? The potential difference across this A and B must be equal to V. That indicates V minus 0 is V volt, 2V minus V is V volt. Likewise, 3V minus 2V is V volt, 4V minus 3V is V volt. Okay, so see here, this is 4V, then this must be 3V. If I apply V by 2 at this point, it must be minus V by 2 at this point, isn't it? So V by 2 minus of minus V by 2 will become what? V, isn't it? Now, I have to apply the voltage across AD. Why? Because we want the, what is called as the resistance across this AD, equivalent resistance, okay? Then, if I apply voltage V, then I will consider this is V by 2 and this must be minus V by 2, okay? Now, this V by 2, this is the V by 2, as one resistance is R over here and other resistance is R over here. So in this resistance R, if you consider in this resistance R, it drops a potential of X. Then here we have X only, right? So V by 2 drops potential something and it will become X over here. Then the same potential drops over here and it must be X. Likewise, minus V by 2, if you consider this is R. So in this R, if it drops by minus X, if V by 2 drops by X, minus V by 2 will drop by minus X. This is the method that you have to remember, okay? So V by 2 drops by X in this R. Likewise, minus V by 2 will drop by minus X in this R. In this R, it will be minus X only. Okay. Likewise, this X in this R, if it drops by Y, this minus X in this R, it will drop by minus Y. And as you can see, this x minus x is 0 volt, this y minus y is again a 0 volt, so this R has no meaning in this circuit. This R has no meaning in this circuit. So we can redraw the circuit and the circuit will become very easy now. Right? So we have, this is point A, this is point B, this is R, then this is point E we have, this is R, this is A, this is B, then this is point D, this is point C, we have, this is R, again B to C, this is R, D to C, R, then we have, this is R, and E to F, no need to draw. Why? Because the potential across, potential at E and potential at F will be the same. Right now, so no need to write. So this is R, this is R. Now, as you can see, the current in this branch will be the same. That's why this R and this R are in series. So equivalent of this will be 2R, which is in parallel with this. This 2R is in parallel with this R. And we can write 2R into R divided by 2R plus R, which is equal to 2R divided by 3. Likewise over here, this is 2R, right? So this is 2R by 3 plus this R, 2R by 3 and R are in series. So R equivalent for this series combination, we can write 2R plus 2R divided by 3, and as you can see, it is 8R by 3. So total equivalent for the series combination is 8R by 3, which is in parallel with R, which is in parallel with 2R. So therefore, RAD we have is 1 by RAD is equal to 1 divided by R plus 1 divided by 8R by 3 plus 1 divided by 2R. 1 divided by 2R. So 1 by RAD is equal to, this is 8 by 8R plus 3 by 8R plus 4 divided by 8R, which is equal to 15 divided by 8R. And what is RAD then? That is the total resistance across AD is 8R divided by 15. See, once you identify which resistance has no use, it will be very simple to calculate the equivalent resistance, isn't it so? Right. So this circuit, initially if you see, it will be like it is like a very difficult circuit, isn't it? But once you apply this method, it will be very simplified, very simple circuit, right? That circuit can be solved by the amateur boy, isn't it? Okay. So the next one we have, and that is the B. Across AB we want. So same method you have to apply. I'll redraw the circuit over here. So this is the first resistance, second resistance, third resistance, fourth resistance. Then we have, these all are the resistance we have. This is A, this is B, then C, D, E, F. This is C, this is D, this is E, this is F. Okay, now, so I hope this is clear now. Right. So we want across AB now. This is R, all are R resistances. Now, see here, across this A, what you have to consider? V by 2. Across this B, what you have to consider? Minus V by 2. Now, in this R, if you consider it dropped by X, right? In this R, it has to drop by X only. Likewise, in this R, if you consider minus X, then in this R, it has to drop by minus X. Indicates what? This resistance and this resistance has no use. Why? Why? Because potential at D and the potential at E are same, so no need to use this. Potential at this C and potential at F are same, so that's why no need to use this R. Now the circuit will become very easy. So I'll just redraw the circuit which is equivalent now to this one. Now this circuit you all can easily solve. What is there in this circuit now? This is R, this is R, this is R, this is R, this is R. All are R. Now what is there? Nothing, isn't it? These three resistances are in series, so it is 3R. These three resistances are in series, this is 3R and this is R. So 1 divided by RAB will be equal to 1 by R plus 1 by 3R plus 1 by 3R, and we have 3 plus 1 divided by 3R, which is equal to 5 by 3R. And what is RAB now? 3R divided by 5. See here, it's very simple, isn't it? Right. So once you know how to apply this method, it will be very simple. So first answer we have is 8R by 15 and second answer we have is 3R by 5. Okay. So what you have to consider, across AB V by 2 minus V by 2. If in R V by 2 drops by X, in the same R minus V by 2 will drop by minus X. This method is universal, you can apply anywhere. Okay. Chalo, next. Now in this method, now in this problem, as you can see, this is A given and this is B given. So over here, one short circuit point, as you can see over here, this one and this one, that means the single wire. So whenever single wire is there, so you can consider this point as X, this point again, it must be X. So you can redraw the circuit like A, B. Always try to draw A and B at the extreme ends. Whatever left out points are there, that must be in between this A and B. Chalo. So write down this X point, we have only one point. Okay. So between A and X, this 6 ohm resistance is there. 6 ohm. So strike out that. This is 6 ohm. Between this A and X, this 4 ohm resistance is there. Between B and X, 2 ohm resistance is there. Between again B and X, 8 ohm resistance is there. Now see, it is very simple to identify, calculate the resistance between A and B. Tell me, what is this combination? Parallel, 6 and 4 parallel, 6 into 4 divided by 10. 2 and 8, again parallel. 8 into 2 divided by 10. So RAB, right, RAB is equal to 24 divided by 10 plus 16 divided by 10, which is equal to 40 divided by 10, and that is equal to 4 ohm. So see, it is very simple if you know this kind of tricks, right? So I hope this is clear. Now the next problem. Now see here, we want what is the equivalent resistance between A and B points. So same thing here also, right? Same thing here also. What you have to consider, at A V by 2, at B minus V by 2, isn't it? At A V by 2, at B minus V by 2. Now same thing you have to apply. In this 2 ohm, if this V by 2 drops by X, then this minus V by 2 in this 2 ohm will drop by minus X. In this 2 ohm, if this V by 2 drops by X, then this minus V by 2 will drop by minus X in this. Now see, it is very simple. This is minus X, this is minus X, this is not required, same potential not required. This is X, this is X, same potential not required, isn't it? So you can redraw the circuit like this. This is A point, this is B point. This is 1 ohm. This is 2 ohm, right? Then we have, this is again a 1 ohm, right? And this is connected to B with resistance of 2 ohm, right? Likewise, we have from A, we have 2 ohm resistance. This is 2 ohm, and which is connected to this 1 ohm resistance. Now this 2 ohm and this 2 ohm not required. So as you can see, this 2 ohm, this 1 ohm and this 2 ohm, they are in series. So what is the combination of it? 5 ohm. Likewise, this 2 ohm, 1 ohm and the 2 ohm, they are in series, 5 ohm. So these three are in parallel, 5 ohm, 1 ohm and 5 ohm parallel, indicates 1 by RAB total we have is 1 by 5 plus 1 by 1 plus 1 by 5, which is equal to 2 plus 5 divided by 5, which is equal to 7 by 5. And what is RAB then? It's 5 divided by 7 ohm. So I hope this is clear to you all. This is the third question which we have. Now the fourth question. So same thing, whenever you see all resistances are R, or else the symmetric circuit, always apply what is called as the V by 2 and minus V by 2 method. So over here, across A, what you have to apply? V by 2. Across B, what you have to apply? Minus V by 2. So in this R, if it drops by X, in this R, if it drops by X, in this R, if it drops by X, so same minus V by 2 will drop by minus X, and here it is minus X. So X minus X, it will become 0 volt. Whenever you have 0 volt, right? Whenever you have 0 volt potential, so what you have to do is you can detach this point. You can detach this point perpendicular to V by 2 and minus V by 2. You can detach this point perpendicular to V by 2 and minus V by 2. So the circuit will become like this. So I'm removing this point. So see, now it is very simple circuit, isn't it? So as you can see, this is R, this is R, this is R, this is R. All resistances are R. So once you know this method, so see, now it's very simple, isn't it? This two are, because they're in series, and this are parallel, so indicates what? 2R into R divided by 3R indicates 2R by 3. Likewise over here, 2R divided by 3, which is in series with this 2R. So therefore R equivalent in series is equal to 2R plus 2R by 3, which is 8R divided by 3. So the total of this upper part is 8R divided by 3. So as this lower part, that is 8R divided by 3, and this is 2R, indicates 1 by RAB, that is the equivalent resistance across AB, will be 1 by R1, that is 8R divided by 3, plus 1 by R2, that is 1 by 2R, plus 1 by 8R divided by 3. So if you just solve this, 1 by RAB is equal to 3 by 8R plus 4 by 8R plus 3 by 8R, and that is 10 divided by 8R, indicates what is RAB? It is 4R divided by 5. So I hope this is clear. Now the next problem which we have is the fifth one, right? This is the fifth problem. In this also all resistances are R. Okay, so apply the same method. This is V by 2, this is minus V by 2. So in this R, if it drops by what is called as X, in this R it will drop by X. Minus V by 2 will drop by minus X, and this is minus X. So in this, if it is dropped by Y, minus X will drop by minus Y. In this, it will drop by Y, then minus X will drop by minus Y. In this, if it drop by X, Z, minus Y will drop by minus Z. Indicates this is 0 volt, this is 0 volt, this is 0 volt. Oh, what does that mean? This R and this R will have no use. You can redraw the circuit and solve it. It is very simple now. The circuit will be somewhat like this. This is A point, this is B point, this is R again. So all resistances are R. Indicates these 4 resistances are in series, indicates 4R. These 2 resistances again are in series, this is 2R. This 4R and 2R, they are in parallel. So indicates 4R into 2R divided by 6R. So this R, this is 3, that means 4R by 3, which is in series with this 2R. So therefore 4R by 3 plus 2R indicates 10R divided by 3. So finally 1 by RAB is equal to 1 by 2R plus 1 divided by 10R divided by 3 indicates 5 plus 3 divided by 10R, which is 8 by 10R. So what is RAB then? It is 5R divided by 4. So if you apply this method, you will find each and every symmetrical circuit easy, right? You will not find any difficulty, right? So next problem. This is the 6th one which we have. So this is A point. So this is the short circuit. So this is also A point. This is also the short circuit. This is the B point. So there is no other point. That indicates what? Only 2 points are there, A and B, and you can redraw the circuit. If you are not able to find any connection, any symmetry, always try to redraw the circuit so that it will be simple. So see here, between A and B 4 ohm resistance, A and B 2 ohm and 4 ohm, between A and B 6 ohm and 8 ohm, 4 ohm. That means we have between A and B 4 ohm resistance is there. Between A and B 2 resistances of values 2 ohm and 4 ohm. Between A and B 2 resistances of values 8 ohm and 4 ohm. And between A and B 1 resistance of value 4 ohm. Indicates what? This is the combination of 4 ohm and 2 ohm, 6 ohm. This is the series resistance combination of 8 ohm and 4 ohm, 12 ohm. This 4, 6, 4, 12 are in parallel. 1 by RAB is equal to 1 by 4 plus 1 by 6 plus 1 by 4 plus 1 by 12. See, some of you, what they will do, what you all will do is, you will calculate R equivalent correctly. But what you will calculate is 1 by R equivalent correctly. So you have to be very careful. Finally, you have to take the reciprocal also. So here, this is 3 divided by 12 plus this is 2 divided by 12 plus this is 3 divided by 12 plus 1 divided by 12. So which is equal to 3 plus 2 5 plus 3 8 plus 9 divided by 12. Indicates RAB is 12 divided by 9. Some of you will calculate till here correctly, and in option you will see 9 by 12 and you will mark this, and the easy 4 marks you will not get, isn't it? So you have to be very careful, very careful about this, right? So 12 by 9 indicates what? 4 divided by 3 ohm. So I hope this is clear to you all. Chalo, the next question we have, and that is, between A and B, you have to find out the equivalent resistance. Okay, so same method, symmetrical, and all are R. Yes, you can apply. Which method? V by 2 and minus V by 2 method. So in this R, if it drops by X, and in this R, if it drops by plus X, so minus V by 2 will drop by minus X indicate this is 0 volt, this is also 0 volt. No need to consider this R, no need to consider this R. So you can directly apply the series and parallel combination one. So it's very simple now. R, this is R, this is R, and this is R, this is A, and this is B we have. So what is the equivalent of this to 2R? What is the equivalent of this to 2R? Why? Because they are in series, and this is R. Indicates 1 by RAB, which is equal to 1 by 2R plus 1 by 2R plus 1 by R, and that is, this is 1 plus 1 plus 2 divided by 2R, so which is 4 divided by 2R, indicates what? What is RAB then? RAB we have is R divided by 2 ohm. So I hope this is clear. I hope this is clear now. Now the next question we have is 8th one. Now in this also same method, as you can see, the 2 ohm, 1 ohm, this is 4 ohm, 2 ohm, 1 ohm, 3 ohm. So if you just apply like this, we have symmetrical circuit. You can use V by 2 and minus V by 2 method. So V by 2 in this 1 ohm, if it is dropped by X, right? In this 2 ohm, it will drop by Y. In this minus V by 2, it will drop by, in this 1 ohm, it will drop by minus X, and in this 2 ohm, it will drop by minus Y. So here, as you can see, this is 0 volt potential, indicates you can detach this point perpendicular to V by 2 and minus V by 2. So this is 2 ohm, this is 4 ohm, this is 3 ohm, this is 3 ohm, this is 2 ohm, 1 ohm, 1 ohm, this is point A and this is point B. Now this 3 ohm and 3 ohm, they are in series. It will become 6 ohm, which is in parallel with this 4 ohm. So 6 into 4 divided by 10. So which is in series with this 4, and they are in parallel with this 2. So it is 24 divided by 10 plus 4, which is equal to 64 divided by 10 we have. So that is for the R equivalent for series, isn't it? All series. This is 2 ohm, indicates 1 by RAB is equal to 1 by 2 plus 1 divided by 64 divided by 10, indicates we have, this is 1 by 2 plus this is 5 divided by 32. So we have 16 plus 5 divided by 32, which is 21 divided by 32. So what is RAB then? 32 divided by 21 ohm. So I hope this is clear. I hope this is clear. This is the 8th question which we have. Now the 9th question. And now across AB we want the equivalent resistance. As you can see, if you apply over here, the same thing is there. That is the symmetric circuit, right? So V by 2 and minus V by 2 method, yes, you can apply. So in this 5 ohm, if it is dropped by minus X, in this 10 ohm, plus X, in this V by 2 will drop by plus X, in this 10 ohm, it will drop by Y, minus V by 2 will drop by minus X, and this is minus Y. So indicates at this point we have 0 volt, then detach this along this line, and it will become very simple circuit then. So we have, this is the circuit. See, if you solve these 10 questions, most of the questions I took from the standard books only. So you will not face any difficulty and no need to solve any other symmetric electrical circuit, right? For practice purpose, yes, you can solve, but if you do this much also, that is enough. Okay, so this is 10 ohm. Now see, this is 5 ohm and 5 ohm series, so it will become 10 ohm. They are in parallel with this 10 ohm, 10 ohm, that means 5. Again, this is 5, this is 5, 10 ohm. This 10, 10, it will become 5. This will become 5 ohm. Indicates it will become very simple. This is 10 ohm, 5 ohm, 10 ohm. This is 5 ohm. This is A, this is B. They are in series now. This is 25 ohm. So what is RAB? Which is 25 into 5 divided by 30. 5 6 are. So 25 divided by 6 ohm is the answer. So see, it's very simple. Now the last question we have, and that is the 10th question. In this we have A and B. So across this A and B, we want what is called as the total resistance. So if this point is B, this is the short circuit. So this must be B. Short circuit B. Short circuit B indicates we have A, B, and one more point is there, that is C, right? Node point. So I told you, whenever A and B are there, you have to draw it at the extreme ends, and the third point must be in between, or any other points are there, that is, that points must be in between this A and B. Okay, so between A and C, one resistance is there, that is R. Between C and B, three resistances are there, all having value of R. So as you can see, this is R by 3 and this is R. So RAB is equal to R by 3 plus R, which is equal to 4R divided by 3 ohm. So it is very simple if you understand the basics of this electrical network right now. Chalo. Now between this A and this B, we want what is called as the equivalent resistance. So same thing, in this V by 2 minus V by 2. V by 2 in this R, if it is X, minus X. In this R, if it is X, this is minus X. Indicate this is 0 volt. This is 0 volt. No need to draw this. So the circuit will become very simple, and we will have this is R, this is R, this is R, this is R, this is A point, this is B point. Right now, this is for A, this is for B solution, right? So this R and this R, they are in series, so it will become 2R. This R and this R, they are in series, it will become 2R. So what is RAB? So 2R into 2R divided by 4R, so it will become 2 to get cancelled, so it will become R. So RAB for the second one is R, and RAB for the first one is 4R divided by 3. So it is 4R divided by 3, and this is only R. So I hope all these questions are clear to you all. If anyone has any doubt in any particular question of any book, they can comment in the comment box. I'll try to reply to that comment as soon as possible. Thank you so much.